Friends, today I am going to discuss some forecasting forecasting the historical mean. Let's see, I am collecting a data from Kaggle and I am also using here Kaggle platform. So this is the beta way I can collect the data. So let's see, just I have imported numpy as a np and import pandas as a pd, and I am importing a data df will equal to pd.read csv input stats and this type of the data, only the numeric value. So let's see, now I am going to see here this data look like this. So it has been inputted and now look here, it has been imported and data we can see here, and we can see here the head of this data, but I think in this data don't have the any column, it hasn't been mentioned, so need to write here the some column, so we can add here the some columns name, like I am going to here data dot column date and data. So let's see, I can give, I have given a name. Now we can see here the head of this data and it is representing like look this, date has been given and data has been given. So similarly we can see here tail, so tail of this data, so it contains the 62, from it will start from the 0 to 62 means 63 rows with the date, and this date has been given like a quarter wise, look here 33 12 9 6 3 3 6 9 12. Okay, so quarterly date has been given. Now I need to the some informations about the data, so we can easily get here. So there are 63 non 63 here object and 63 floats, but I want to create a data like a null sets. So after creating of this data, because the whenever we see the head and tail, so automatically we can see the first 5 entire of quarterly earning, and similarly we can write here the bottom 5 quarterly earning. So after this we can split this data like parts wise, because this data has been started from 2005 and it end 2020 31st December 2020, and it will started from 2005 36 2005. So let's see, first we can split and specify our the train set will contain all the data like a df except the last 4 entry. So I am applying here -4 means train set, we are going to train a data except last 4. So last 4 in the sense we can see here a tail last 4 1 2 3 4, 59 to 62 is excluded and all data will be trained, and the test set will compose of only the last 4 entries, and I am using the for test only last 4 entries. So let's see these 4 entries, last 4 entries. So I hope it is clear. So train and test of this data. Now let's see, first I am going to the train means historical mean, will equal to np dot mean and train of this data, means except last 4 I am going to get here the mean of this data. So I have gotten, and we can easily, I think why am need to get here something. So so I have gotten here 1.09. This is the mean of this value. So of this training data, means almost you can see the 1.9% it may be possible. Look there. Now after this, the testing of data, like the predictions mean. So I think sometime look like this, and after that we are going to define like a. So first we are going to set the historical mean as a forecast. So my forecasting as a historical mean. So we will newly forecast this value for the each quarter from 2005, and now to do so. So we'll simply create a new column, read underscore mean, that holds the historical mean of the training set as a forecast. After that, next we need to define the calculate the error matrix. Error matrix in the order to evaluate the performance of our forecast on the test set. So in this case, we will use mean absolute percentage error, MAPE. I have already discussed mean square error, mean absolute percentage error, and others. So if you don't know, so I have described each and every one as a details, all matrices, so you can watch my video. So let's see here the return np dot mean and np dot absolute mean and y underscore true and into y underscore rate divided by y underscore true into 100. So I am going to define here. So it has been defined. Now the map underscore hist underscore mean, map test data, and test rate underscore mean, and now I am going to print here. So look here. So it has been printed like a 109. After that, I am going to the plot, because I have gotten mean percentage error is like a 109, so really high. So let's here the import the matplotlib dot pyplot as a plt, and fig ax will equal to plt subplots fixed size 12 6 it depend on you. And now ax dot plot train date I have taken, and train data I have taken, color I have taken the green, and label train. Similarly, we can also ax dot plot test dot date, test data blue color, label a test, and ax plot the test date and test read mean and red color, so label the products, and ax dot set underscore label and date, ax dot set underscore y level earning course here UST, and similarly ax b spans like I am using to 58 to 62 colors, like a 58 total. Yeah, 62 has been given. So this value I am using here because 63 is not included, and I am taking like a 12 quarters gap, so we can see look like a plot here. So let's see. Now I am going to the plot here. So we can understand MAPE will equal to 1 by n sigma I will equal to start from 1 to n, and AI minus Fi divided by AI and into 100. So previous data minus forecasting data divided by the previous value, previous data. Yeah, it has been printed look like this. So it will start from the 2005, and look here 2017 you have getting some volatility here. So here we can see here, so it is a measure the predictions accuracy for a forecasting methods that is the easy to interpret the independent of the scale of our data. This means that whether we are working with 2-digit values or 6-digit value, the MAPE will always be expressed as a percentage. Thus MAPE returns the percentage of how much the forecasting value deviate. So we observe the actual value on average, so whether the predictions was the higher and lower the observed value. So look here, this one is the observed value, so now our forecasting is going the low side, so below. So we can easily understand, so it is going the down, so we can be a careful look like that. So actual value at a point I in a time, and Fi is the forecast value at a point I like in a time. So simply n you can say represent the number of forecast. So in this case, because we forecasting of the like a 4 quarter from 2005 to 2020, so we have taken here n will equal to like this 12. Here you can see here 16, 12. So inside the summations, the forecast value is subtracted from the actual value, and the result is divided the actual value, which gives us the percentage error. So then we take the absolute value of the percentage error. So the operations is repeated for each of the points in a time, and the results are added together. So finally we divided sum by total number of the n has been given in this example we have already discussed. So let's see, after that we have already described each and everything, and we can subplot, and we are using like a data, and the end of this result clearly the baseline did not yield the accurate predictions look like this way, but here is the predictions means it is going to the below. So clearly this baseline is predicting, so now the predicted line is a very it is a forecasting price is a below the predicted line. So since the predicted line is crossing from this test line, so now we know that our forecasts are really being a correct, like so it is a continuously going downward. So look like it may be the something like 109. So look here, it has been going, so you can see that it has been like a 100, and if you count from this point, this is the more than 100%, yeah, approx 109% has been deducted. So predicting the historical mean as the baseline, so we can see that the predictions is doing a very well, like the actual value at the test sets. So the baseline is the given like a 109. Oh, sometime, so 100% you can't say anything is correct, but this in this data we are looking like a correct. So we can see the positive negative trend as the negative trend. And so how can you improve our baseline? So let's see, the before moving on the next sections, like we can, so we can think a way to the improve the baseline while they still using the mean. So do you think that taking the mean of a shorter and more recent period of time would help from 2005 to 2020? Similarly, if I want to forecast like mean last year mean, so let's see, if I want to forecast, look here, last year mean, so if I look last underscore year underscore mean will equal to np dot mean and like a trend dot data, and I think I have taken like sorry for that, minus 4 and this is a slash like this. Now the print last underscore year underscore mean. So you can see here, so last underscore mean is 1.04. So now this is the average for the last 4 quarters, average mean, which is the last 4 data point of the trend sets. If you want to predict like this, like a test and underscore, yeah, test ILO dot lossy log, and I think I discussed like a this way slicing and slicing, and then I have written like a something paid underscore last underscore YR underscore mean. Right. So don't need to, you can put here the single bracket and double bracket, doesn't matter. And this will equal to the last underscore year underscore mean. Last year mean. So let's see, print underscore, and this one as will look like this. So last mean, and after that we can create the MAPS like this. So actually I am going to the create the last only, so I can write here. I have already done this one, so let's try here, print, and something look like this. So it gives last year mean and map test data and print here. So I test this set here, and we can get the some a specific value like this, because test and data and predict has been given. So what I did get is some mistake here. What's it, print underscore dot last year mean, print underscore last YR, last YR, and last year mean. Okay, print test underscore last yeah, I have written the only one time, don't put here the double times. This is my mistake, I think. Yeah, 1040, and now we can calculate here 1040. So let's see. So this is the way we can easily predict, and now the last known value we can apply here. So I hope you can understand how to predict like this, and after that we try to understand, because we can understand here the 9%. Okay, so don't think about this here. So and we are taking the last value, and also we have discussed first value, but this is a way we can easily understand predicting the using the last known value. So I hope it will be helpful for someone. Thank you.